Welcome everyone to another interesting DSA problem which is titled as Binary Tree Inorder Traversal. So let's try to understand what is a problem statement. And before moving into the problem statement, here it's already mentioned about the constructor of a binary tree. Just like linked list, here one particular node will have two pointers going out from it. One is left and another is right. So this is left and another is right. So this is the constructor definition. So let's try to understand what it's trying to say. We have to return a list in such a that the values inside each node should be traversed in such that it should be in order traversal. So let's try to understand what is the concept of in order traversal. To understand that, we can understand this core idea. Basically, first you have to visit the leftmost nodes, then go to the root, then go to the right. I will try to explain it with this particular fundamental idea. Suppose this one is this root. So before printing or before saving the value of this particular node, we should make sure that the values of all the nodes which is left to this particular root should be traversed before saving or printing this particular value. Similar concept would appear to this 2 also. Before printing this 2, whatever be the nodes appearing left to it, this is 4, should have appended or printed into our list which we are planning to return. Similarly, for this particular node, whatever it's left should be printed. So that's why the left, then root, then right is happening. So let's try to build the list which we need to return. So the only information given would be the pointer root. So what we need to do, we need to go left. Again, if the possibility of left is there, we should again go to the left. At this node, we cannot further go to the left. Then we can access this value of this node. Then what we can see, we can go to right. We can see whether a possibility of right or not. No, there is no right. Then go back and print this value 2. Then go to right. And whenever we go to right, whenever there is a possibility of this right, we should check whether that particular right has a possibility of left or not. If there is a possibility, we should first save this value, then go back and then print this thing, then go right, then print this thing. You will understand what does it mean. So what will you do? Okay, we go here left, then we again go here. Yes, from here we cannot go further to the left or further to the right. Okay, once we cannot go further to the left, then we print out the root. That is 4 is saved, there is no right. Okay, then go back to this 2, then 2 is saved. Then further we can go to the 5, but 5 has an option to go left and right. Then go first to the left, then 6 is saved. Okay, then go back to the 5, then 5 appears. Then go back to the right, then 7 appears. Okay, at this point, whatever be the left to the root 1 has been saved. Then save 1, then go to the right. 3 don't have left or right. Okay, then that it has right but it don't have left. It don't have left but it has right. So before printing right, the root 3 itself has to be printed or saved. Then we go to the 8, but 8 does have a left. So first print this 9, then go back and print 8. So this is what, just see how we are traversed and saved. So when you follow this thing which I mentioned, this would be, the output would be, let's write it properly. The output would be first this 4, then 2, then before going to this 5, because 5 has a left, 6 will be coming here. Okay, this is one, first, second element, third element, then fourth element will come here, that is fifth, then this will be the fifth element, that is 7, then this will be the sixth element, that is 1, then this will be the seventh element, that is 3, then this will be the eighth element, that is 9, this will be the ninth element, that is 8. So this will be the list we are going to print here, 4, 2, 6, 5, 7, 1, 3, 9, 8. I hope you understood what does it mean by in-order traversal. I will quickly go how it's printed. Okay, this, then 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 this. See how it has traversed. So how we can code it and how we can understand. So there is a simpler explanation. Let's copy few of the things like this particular example, like we can copy to the next page and we can just try to code by understanding it properly. Let's make some space here. Pasted, yes. One approach is, the most intuitive approach is by recursive method. So approach 1, recursive. So let's write the class and method definition and everything. Class solution, define in order traversal. What are the information provided? Just root is provided, that is nothing but an optional tree node. Root is nothing but an optional list node, optional tree node here. We need to return a list of integer. Okay, then let's go to the solution. We just need a array or list which we will be returning it soon. We will be appending element as we traverse in order fashion, and I'm going to, for recursive purpose, I'm going to design a function that we will call again and again. So that would be define in order, and one thing, it's like you can write root or node, anything. So this one argument, that would be an node. A node will be passing through here. Okay, and whenever this if node is none, basically if the node is none, that is a base case. Okay, just return. So this is a base case. Let me comment out base case, because all the iterative thing need a base case. This is a base case. And what I'm going to do, first I have to reach the leftmost part. For that, whatever be the node we have given, we have to again call that function. This time call the leftmost one, node.left. So this particular step will take us to the leftmost thing, and once we are at the leftmost thing, okay, then what we need to do, we have to append that to our result. When it is in leftmost thing, it will come across the base condition, then that will make sure, okay, that is the leftmost thing, and that point we just need to append that result dot append node dot value. And once we edit, we also have to check if there is any right portion or not. In order, this will also create some kind of a repeated equal node dot right. This particular function we will call again and again, starting from the given root. So let's call that in order root, and at the end we just need to return result. So let's try to understand how it is going to call. I am going to use here. So first I am going to write it as from the value point of view. The representation would be the value point of view. First we will be calling, where should I write? Okay, first let me make it a bit smaller. All these things, I'll try to make it a bit smaller. Okay, yes. First I will be calling in order root, that is nothing but the node of 1. This node I will call. Once this node is called, it will like start in order the node with value 2, then this will call in order the node with value 4. Here it won't be having a left node, because once you are here it won't be having a left node, so that time it will return. Then we would be appending here. Next step would be in order none. So this will create the return statement. Then that point, what will happen? We will be appending result dot append. At this point it will be result dot append 4 will happen. Then when it go back, before going back, it will also check in order node dot right. So there is no in order, there is no right here. Okay, then it will go back to, then it will again append 2, then it will append 2, here it will append 2, then it will go to the right, that is nothing but 5, but here the 5 does have left. So first it will go here, then it will come back, then this will be saved. So like that iteratively it will keep on going. So intuitively you can understand by this time how this recursive thing will work. Like first it will go to leftmost, then whatever it goes back and it will print out or save in a manner which we needed. So another thing is, can we do it a bit slightly different? So let's try to understand what is the time and space complexity. So since we are iterating through the entire graphs one by one, everything, so time complexity would be order of n. Space complexity, we are using the recursive method and we are using the list to store everything. So here order of n, this is for recursive stack, because this stack, whatever this recursive stack is storing elements. So for this thing, space complexity, recursive stack would have a space complexity of n. Okay, but is there a better method? For that, let's copy this fun information again. Let's paste it here, resize it better. Okay, yes, there is a approach 2 available, approach 2, iterative method using stack. So basically this would be simulating whatever the recursive thing which we had did using the same kind of approach. So let's try to write by the information class solution, define Inorder, traversal, self, root is given, nothing but optional tree node. Then we need to return a list of integer and result, this is the one which we need to return, and stack, another list we will be using, and I am going to use a variable or a pointer current initially assigned to root. What I am going to do, I am going to check whether current pointer exists while current or the stack is non-empty or stack. We will understand one by one. Then what I am going to do, I am going to go like take this current pointer to the leftmost while current exists. While I am going towards the leftmost point, for example, I am going to start from here. While in this journey to go to the leftmost, while jumping from one node to another node in the left side portion, whatever the value or whatever the node I am going to encounter, that will be appended to the stack. That would be happening. So this would be appending initially, then I will append this, then I will append this. Then I can pop out from the end. That is my idea. So what I am going to do, while current initially it's at root, then I am going to append stack.append current. Let me make this. So first what will be appended here, the one node appended here, then current would go to current dot left. So this will jump from here to here, then 2, next 2 will be appended here, then 4 will be appended here, because it from here to here. Then what I will do, once there is no further left, then I am going to take the pointer current, okay, that current pointer would be at stack dot pop. That's nothing but the current pointer right now would be here, current, and I am going to append the value of that current pointer, result dot append current dot value. Then I will take this current to the right if there is any existing right. Here in this case there is none. If exist, I will take it to the right side, current equal to current dot right, and I have to do it again and again. If there is no current dot right, what is going to happen? It will again check. Next step, it will check while current. If there is no current dot right, it's fine, but there is stack. Okay, there is stack, but this particular portion will not execute because it's for the current pointers to go deep down. So here next time what will happen? Current dot pop. If the 4 is already popped here, in this case it's 4 already popped, next one would be 2 would be popped, the current would be here next time, okay, and the result is getting answer like 4 2, which we have already seen here, like 4 2, see, it's getting stored in the same fashion, okay. Next time it will be 5. So basically we are simulating. We can, okay, if you required, we can again go, when you go to current dot right, yes, if this here, in that thing, the current will again take you to the current dot left. So while going, what happened? It will again store 5, then again go to 6. Next time while popping out, this will be popped out. So it will be 6, then 5 would be popped out, then 5 will come here. Okay, then it will again go to 7. Okay, then 7 will come here. Okay, it's like we are simulating the iterative thing we discussed as approach 1 in this particular method. So take a moment and try to understand how both of this particular approach 1 and approach 2 are pretty much similar. At the first time this could be a bit intuitively different to understand, but you can see in the approach 1 we are going to the leftmost, then again go to the root, then again go to the right. Same thing we are doing, simulating using the concept of stack. So once this is done, what we need to do is that we just need to return here, return the result. So what is the time complexity of this particular method? Time complexity is order of n, space complexity is also order of n. And I hope you understood this particular problem of binary tree in order traversal, and thank you for listening. Thank you.